So for this problem, we have a manufacturer. They're producing two different types of baby dolls. And they want us to find the number of dolls of each so that it would produce the maximum profit. In this problem, they're not specifying what variables to use, like some of the earlier problems. So for this one, I'm going to go ahead and choose let my number of first baby dolls be F. F for first, and therefore for the real babies, I'll go ahead and use R. Now, since we are looking at number of dolls, we know we can't have a negative number of dolls, so we're going to go ahead and say F has to be greater than or equal to 0, because we can't have a negative number of dolls, and the same thing for R. R has to be greater than or equal to 0. Now, once again, our other restrictions come from, or other inequalities come from the limitations or the restrictions. And in this case, they're giving us a couple. We have to have a maximum of 48 hours, and they must produce at least twice as many first babies as real. So let's go ahead and take a look at a couple of things. So as we look at this, we have our first restriction of 48 dolls. Now some of that's going to come from, or not 48 dolls, 48 hours. So we're going to have some hours that we use to make first. Then we've got to add to that hours to make the real babies, and we know that has to be less than or equal to 48. We also have our other restriction that we need to produce at least twice as many first babies as real babies. And we'll work out our inequality here in a little bit. But we're going to go ahead and do a side note now so that we can try to help us understand that first equation of how many hours we're using for each one. So as we're looking at the side note here, how many hours does it take to produce 32 first babies? Now, up here, you know, for first babies, it's 8 babies for 1 hour. So then how many hours would it be for 32? Well, that would be 4. So my question is, what is it that you're doing to the 32 and that 8 in our problem to be able to come up with that 4? Well, in this case, we're going ahead and dividing them. Now, if you think about what those numbers represent, what does the 32 represent? And that represents the number of first babies, which we're calling F. And then the 8 represents the babies per hour. So really, all we're looking at here for this problem is if we follow the pattern of what we're doing, we need to take the number of babies, according to this right here, number of babies, which is F, divided by the 8. That's how we end up coming up with the hours to do our first babies. Now, if we do something similar for the real babies, so up here, once again, for real babies, they can do 20 per hour. So if we have 60 real babies, we end up getting 3 if we're doing 20 an hour. So question is, what are you doing to that 20 and to the 60 to get our answer of 3? And in this case, we're taking the number of babies of 60, dividing it by 20, which is the per hour. So what does the 20 or the 60 represent? It represents the number of babies, which is R. And what does the 20 represent? That's number of babies per hour. So for our problem then, it's R, the number of babies, divided by 20 is really what we're going to be looking at. So with that in mind, if we write that out, first babies divided by 8, real babies divided by 20. By the way, before we do the bottom one, we'll go ahead and do the profit, and because that's farther up on the screen, then we'll get that out of the way so we can deal with that later. It's $3 for each profit on the first baby, so it's $3 times F. Then we've got to add in the profit from the real babies, which is $7.50 for each real baby, so we get this. So now let's go ahead and consider the situation where we need to produce twice as many first babies as real babies. Now, suppose we had an equal sign here to begin with. It's not equals, but suppose we did. You want to think about, if we need twice as many first babies as real babies, which side is going to be bigger? Is F going to be the bigger, or is the real going to be the bigger one? So if we need twice as many first babies, that means the first is the bigger one, the real is the smaller one. So you need to ask yourself, which side do I need to multiply by 2 so that they'd be equal? Well, if I multiply the bigger side by 2, that's going to be bigger yet, and that's not going to be equal to something that's smaller. If this side's smaller, if I double that, it would likely then be equal to my bigger side. So I need to double the smaller side so it's equal to the bigger side. Now we can deal with that inequality. We need to have at least twice as many first babies. So the first babies has to be that or more. So first has to be equal to this, or it has to be bigger. So that means it's really F greater than or equal to 2R. Looking at the next slide here, we can then go ahead and graph those. We can make ourselves a t-chart, plug in 0 for our F, that knocks this out. Then we have R divided by 20 equals 48. Then we go ahead and we multiply both sides by 20 and we get this. And then we want to consider the other intercept when R is 0. So if R is 0, 0 divided by 20, that knocks that out. So then to get F by itself, we'd have to multiply by 8 and we would get this. Now, looking at this over here, if we plug in 0 for F, we also get 0 for R. This one only has one point that helps us when we're looking at the intercept. So we really just have to find some other point to help us. Now over here, these are relatively big numbers, so I'm going to just try a somewhat big number like 300. Plug 300 in for F, I can solve it for R, and I end up getting 150. So all I have to do is graph these points. So this first one, I got to go over 0, up 960. So I'll go over 0, up 960, and I'll plot that point. Then I need to go over 384 and up 0. So I'll plot that point. And I'll mark it. And now all I have to do is go ahead and draw in a line in between those. Because we're less than we would be shading down here in the triangle. And by the way, I'm only looking at the first quadrant because F greater than or equal to 0, R greater than or equal to 0 is only the first quadrant. Now notice when I did my t-charts, I chose to do F and then R. F is in the normal X spot, so I'm putting that on the horizontal axis where X normally is. R is in the normal Y spot, so that's why I have R in the normal Y spot. So now I need to go ahead and plot these points over here. So I have 0, 0, which is the origin. Then I have to go over 300, up 150. Over 300, up 150. Now, that's still not a whole lot, so I could maybe try another point, and I could plug in something for R or for F. It would not make a difference. Now, if I did try something bigger for F, like 600, I would then get a 300 here. So I could go over 600 and then up 300. So now I could go ahead. When I look at this first blue point, I know where I am left and right, but it doesn't touch the axes. But I could go ahead and draw in my line. Now I have to decide if I want to shade above in this triangle or below in this triangle. So I could go ahead and try a point that's not on my blue line. So I could try this point here in red, which is this right here. So if I plug that in, F being this of, if I tried that point 384 and I plugged in my corresponding 0 over here, I know that 384 is greater than 0, so that side, I tried this point here and it worked. So that means from the red over here, I was shading in the big red triangle. When I'm looking at the blue, I tried this point, so I got a shade on that side of the blue line. So I'm really only dealing with this area right here. So then all I have to do is take my blue corner points and then plug them into my profit equation. Well, this one here is the origin. That's easy to find. Because this was on our red line and we found our intercepts, we have this point here. We then have to find our point where the red and the blue cross. Well, those are just the equations, not the inequalities. So you could either look at it like this and you could maybe do substitution, or you could look at it like this and you could do matrices. Either one will give you the coordinates of your point that you're looking for. Then you want to try these 3 corner points into your profit to see which one produces the max.